everyone, now we're going to talk about the last type of indeterminate power, which is 1 to the infinity power.
So here's one example. The base here goes to 1. The exponent over here, as x going to 0 from the right side. Now this is a graph for cotangent of x. As x goes to 0 from the right side, along the curve right here, you see cotangent of x is going to positive infinity. So you see this exponent over here goes to positive infinity, and the base here goes to 1. So this is 1 to the infinity type. It is an indeterminate power. So again, we use our strategy. We're going to let y be this function over here. Okay. Y equal to this. And then we're going to take ln of this y. When we take ln of this y over here, ln of y will have this cotangent x in front of ln, and times ln of parenthesis 1 plus sine of 4x. Okay. Now, as x going to 0 from the positive side, cotangent x is going to go to infinity, and ln of this going to 0. So this is the type 0 times infinity. Do you recognize what is that 0 times infinity type? That is an indeterminate product. Okay. Now to deal with indeterminate product, remember we need to have a CPR, right? The CPR that we perform is we're going to keep the complicated function on top in the numerator. So we want to choose a complicated function to stay on top of this quotient. So I think this one is more complicated than this one. So let's keep this one to the numerator. And then we're going to divide by the reciprocal of this function. Remember, the reciprocal cotangent x is tangent of x. So we're going to divide by tangent of x. So let's see what type is this. So this is a type 0 over 0. As x approaching to 0, tangent x goes to 0. And this numerator here approaching to ln of 1, which is also 0. So it is a 0 over 0 type. Actually, I should make this one red over here, because that is the one of the two emergency type right here. So I'm going to make this one red over here. Okay. So we're going to rush to the hospital and apply L'Hopital's rule directly. Okay. So we're going to differentiate this numerator. The outer function is ln of u. The derivative of ln of u with respect to u is 1 over u. So it's going to have 1 over this 1 plus sine of 4x over here, times the derivative of this inner function, which is going to be cosine of 4x, and then times the derivative of this innermost function, which is going to be 4 over here. Okay. So you have to use the chain rule to differentiate this right here. And don't forget the derivative, this inner function here is 4. So times 4 here. Now the derivative of this tangent of x here is secant square of x. Okay, so that will be secant square of x. As x going to 0, sine of 4x here is going to go to 0. Cosine 4x is going to go to 1. And secant of x is going to go to 1. So when you substitute 0 into x over here, you're going to get 1 times 4 over 1, which is going to be equal to 4 over here. So this is the limit of ln of y. But we're not done. Remember, we're trying to find the limit of y. So if ln of y goes to 4, then y is going to go to e to the 4 power. So this will go to e to the 4 power right here. Because y is the same as e to the ln of y. If ln of y goes to 4, then e to the ln of y is approaching to e to the 4. So e to the 4 is the final answer over here. Now, this is the end of this example. And this is the last type of indeterminate power that we talk about. Okay. So I hope you have fun learning the indeterminate power today.